So, hi guys. Today's question is check if a number is a sum of power of 3. Uh, okay, what does this question say? We are given an integer. Return true if it is possible to represent n as a sum of distinct powers of 3. Otherwise, return false. Okay, it is said that we are given an integer, a variable of integer data type, and the output should be a boolean value, either a true or a false. We need to return true if we can represent n in terms of sum of powers of 3. If we can do so, we can actually return it. Otherwise, we need to return false. And integer y is a power of 3 if there exists x such that y is equals to 3 power x. Okay, now let's check this. Uh, Example, input n equals to 12. Okay, output will be true because 12 can be represented as 3 plus 9, and 9 is a power of 3. So 3 power 1 plus 3 power 2. So that's it. 91. 91 can be represented as, guys, let's check. Uh, what is 91? Okay, if we take the prime factorization, 3 27s are 81. 3 3s are 9, 9 3s 27, 27 3s 81. So 81 plus 90 plus 1. Sorry, 81 plus 9 plus 1 would be 91. And 21. 3 6 are 18 plus 3, 21. And 18 can't be represented in any way. Uh, what if we take 15? 15 plus 6, 15 can't be represented. Okay, we need to define a logic now. And how could we define a logic? For example, take 12. 12 can be presented as 9 plus 3. 91 as it can 91 can be presented as 81 plus 10. But see, 21 we can't represent it as powers of 3 because let's take 12. 12 when divided by 3 gives 4. 91 when divided by 3, what does it give? It 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 doesn't give us a 0 as a reminder. 3 threes are 9, so we'll get 1 as a reminder. 21 we're getting 0 as a reminder. So this doesn't happen. So what's the best way to solve this sum? Let's check. Hmm, 12 can be represented as 9 plus 3. So I think we can actually see, the thing is to break the given number sum as different parts. 12 can be represented as 9 plus 3. 91 as 81 plus 3. So breaking the number to nearest 3 power would actually work. What is the nearest 3 power here for 21? 3 square is 9, 3 cube is 27. 27, it's not possible. If it is 9, 9 plus, we need to take 12. And how can we represent 12? 3 power 1 plus 3 square. But 3 square is already being in use. So we can't use it, I guess, because some of distinct powers of 3 should be them. So 3 square can't be repeated again. So that's the problem. See, I think we can use dynamic programming here. Uh, you might ask me why so. See, we need to actually tabulate the values. 3 square, 12 can be represented as 3 power 1 plus 3 square. It's being tabulated here. Whenever we take 21, we got to know the nearest 3 power is 3 power 9, which is 3 square. Since 3 square, it should be 3 square plus 12. And since 12 also contains 3 power 1 plus 3 square, and since we need only distinct powers of 3, it is rejected. Otherwise, we can do one thing. We can take a data structure of the numbers that can be used. See, let's take 91 as example. 91 means 3 power, it's 81. Nearest 3 power is 81. And then we were left with 10. 81 is 3 power 4. So we have a chance to use other threes, other powers. That's why we can represent 10 with respect to 1 plus 9, and 9 is 3 square. So that's why we would have really represent it. So how can I do this on my own? And the problem is I don't know dynamic programming. That's the problem. So let me see how can I do this. Mhm. I think is it possible for us to store it? I mean, let's take an array and store the nearest 3 power. I mean, that's not the case actually. 91, 3, 27 or 81 actually. How could we find the nearest possible exponent of this? We can't actually, right? Uh, Not true. So we need to figure out the nearest 3 power to given number. How to do so? That's the question. So for 12, it is obvious that 9 is the nearest number. Even for 21, 9 is nearest. So how could I decide that? The only way I could decide which 3 power is nearest is having a list of all the 3 powers. Because let's consider the input size. Input size is literally 10 to the power of 7. And 10 to the power of 7 means I can't actually take that easily. I can't take an array and decide which 3 to the power is close to that. Mm, that seems pretty unpractical to me. 12 is divisible by 3, even 91 too. Okay, let's try brute force approach only. That is what I have got in my brain till now, because I don't know any other approaches. Since I'm new to DSA, I don't know DP. Let's try. How much shall we take? It is given 10 to the power of 7, na? So let me check. When do we reach 10 to the power of 7 near 10 to the power of 7? 3 power, what would be 3 power? Let me check. Uh, 3 to the power of 10 will won't work. 3 to the power of 1000, I think 100 is only pretty big. Let's check. 3, scientific. 3 to the power of 100. Okay, I don't know what is 5.8 or 47. What is 3 to the power of 100? That's way big, buddy. What if 3 to power of 50? See, which 3 to the power lies lies just below 10 to power 7. 3 to the power 14. 3 to the power 14, it is ending. So let's have an array with all the 3 to the powers. I think this approach works. Let me check. I know it's pretty blind approach, but let's define this. Int power array is equals to new int of whether it accept this size, I don't know, but let's check. How many do we need to take? It's 14. For int I is equals to 0, I less than power dot length a plus plus power of I is equals to 3 math dot power. How to use power in Java? Wow, 3 comma I. So now we have an array with possible values here. Now let's do something. We need to find the nearest value. Find the nearest power of 3 for the given number. So what we can do, we can take basically, so how would the array look like? Let me tell you how would the array look like. First it would look like 1, then it would look like 3, then it would look like 9, then it would look like 27, then 81, 81 into 3, 324, 243. So 243 into 3. Let me tell you, 243 into 3. 729. So 729 into 3, 2187. So it's growing exponentially. Now, we need to figure out the value that is smaller. Now, how we can do so? For int I is equals to 0, I less than, what we can say? Our dot length I plus plus. Mm, if now what we need to return? We need to return the value of I that is the highest. Let's take this. Mm, let's name an integer. Int max index equals to 0. If power of I less than n, power of I is less than n, then max index is equals to math dot max of math index comma I. So from this code we can figure out the maximum power we can get. Mm, okay, we can figure out this now. So let's write a function for this. I guess we need a function here to figure this out. Define, oh my god, public static public void difference int n comma int of our So now index I will have comma in max index. Hmm, what I want to do is I want to call this recursively. And why so? That is because what if I calculate? I got the maximum nearest power of 3 right now. Now, let me check. Hmm, yeah. After this for loop is done, I'm going to call this method again with the difference, I guess. Diff of the difference. That is, what do we have here? Hmm, nearest power of n. So, power of max index n minus power of max index, comma, int power, which is power again, comma, max index would be 0. Since we already know the max index right now, yeah, what would it return? Let us check. See, first of all, we have 12 here. 12's nearest index would be 9. So it's square. If 9 is subtracted, we'll get 3. 3 can be obtained directly. Nearest power is 1. Now, what would be the base case? Public void difference is one thing. Public boolean, let's make this public boolean difference. If n equals 0, return true. Is it possible? I mean, let's take the difference again. So we also need to make sure that we take unique indexes, right? So in order to make sure that we take unique indexes, since we have already got the max index, let's do one thing. Int power of max index int max is equals to power of max index. Then we make this guy 0 because this guy shouldn't be accessed again. So we make this guy 0. Then max. If n becomes 0 in this case, consider 91. 91's nearest power would be 81. If 81 is subtracted, the difference would be 10. Now we need 10. 10's nearest power would be 9. If 9 is subtracted, we need 1. And 1 is also obtained from the array. Yeah, guys, I guess splitting it and doing it would be easy. I mean, we are searching here. I think we can use hash map here though, but let's just adjust with recursion for some time since I don't know much. I'm getting some thoughts, but let me check with this one first. So first, if n becomes 0 in this case, then it is true. Okay, return if n is less than 0, return false. I think this would work. I don't know, yaar, I just feel that this would work. Return diff of n comma power comma 0. Let's run this. What happened? For int alien GTH is correct only, na? I less than power. Here is the mistake. Why it is pointing over there? Max index is already defined in the method. Okay, let's not define this guy. Hmm, lossy conversion. Okay. Since it's a lossy conversion, we need to convert this into int. Even then, I have some issues. Runtime error. I don't know whether this is possible or not. Why would it show a runtime error? If n is 0, we're returning true. If n is less than 0, we're returning false. Static. This is out of my conditions. I need to use ChatGPT now. Debug my code. Your code has features that cause incorrect behavior. Sequence. Let's check if this works. What is different in this? Let's first run this. I don't think it will work. Yeah, 91 call it is working. For 21 it's not working. It's showing true. It fails. So 21. Here he's using greedy approach. So one thing I understand is I'm conceptually weak in this area. I require some knowledge first rather than solving it. I tried my best. Let's look into the editorial because since I don't know how to solve this, how much time I spend on it will be a waste. And guys, this is a lesson. See, sometimes you don't know a sum, and it's good that you don't know a sum because you will get to know something from it. Since I don't know how to solve this sum, I tried for more than 25 minutes as you can see, and trying more than that will be a time waste because I don't exactly know the approach to solve this problem. So let us learn it. Editorial. We're given an integer and determine, okay, this is exactly the question here. In other words, we want to know if we can choose some of the numbers, each used at most once, such that their sum equals n. So we have a generalized mathematical approach where all exponents are unique and non-negative. You need to return true if sum exists, otherwise not. Approach 1 is backtracking. Backtracking is something that I don't exactly know. Intuition. An important observation is that we never need to use power of 3 larger than the given integer n, since that would immediately make the sum greater than n. Since n can be as large as 10 to the power of 7, the largest power of 3 we need to check is around 3 to the power of 15 because 10 to the power of 7 approximately equals to 3 to the power of 15. Given this, we can use backtracking approach to explore all possible ways to represent n as a sum of distinct power of 3. One thing that I'm happy about is I just came through the same approach. Instead, I used 3 to the power of 14. Okay. Hmm. Given this, we can use backtracking approach to explore all possible ways to represent n as a sum of distinct powers of 3. At each step, we consider whether to include or exclude the current power in our sum. For a given exponent power, see, they used backtracking, I used recursion. I don't know which one's correct. But I guess that's similar. I don't know. Include 3 to the power, reducing our target to n minus 3 to the power, and proceeding to the next exponent. Skip 2 to the power and try to form n using only higher powers. We have two choices. Hey guys, what? I included the same type of logic, but I failed at some. If n is 0, we return true. Exceeds n, we are returning false. Finally, it either recursive call returns true and conclude that n can be formed using distinct process. Okay, since I'm not familiar with backtracking, I need to explore this. It seems. Hmm, okay, we can learn about this. I'll just resume into the sum once. So what did he done? I don't know, guys. This is pretty big. Optimize iterative approach. Use something else. To optimize the previous approach, we aim to reduce the number of cases the algorithm checks. We can simplify the process by working in reverse, starting with the largest power of 3, and that is what I have done, right? If n is greater than or equals to the current power, skipping the power is always lead to a false result. This is because the largest sum we can achieve with small powers is the sum of all the lower powers, which is always less than the current power. So if we skip this power, we can't form the sum n, and we must include it by subtracting it from n. Guys, I did the same thing, I guess. Mm, Initialize power to 0. Find the largest power of 3 that is smaller than or equals to n. Yeah, this is what I have done in my code, the previous code that I have done, my code. See, I found the nearest power of 3 given number. While n is greater than or equals to 0, if n is greater than or equals to power of 3, add to the sum by subtracting it from the n. How close is my code to this algorithm? Treating over an array, the correct approach to find is dynamically using while. It was return false. Your code resets used powers to 0 in the array, but it doesn't explicitly prevent using the same power. Actually, I'm not near to it also. I just understood the base logic. So let's run this, buddy. So let's understand this once. We are figuring out the largest power of 3 that is equals to or smaller than n. Then while power of 3 power plus 1 less than or equals to n, increment power by 1. We are using max power here. Max dot power of 3 comma power. Since we are updating power using a while loop, we are getting if n is greater than or equals to max power, n is equals to n minus max power, subtract the largest power. Mm, exactly to say the equation power plus plus. We are finding the largest power first. Then we start subtracting the power of 3 while n greater than 0. We are taking max power as 3 comma power. So first we have some value for the power which will be the max power. Then what we are doing where if n is greater than or equals to max power, we are subtracting the max power from the n so that we get the difference. Then if n is greater than or equals to max power, then if needed again, I mean if n is greater than the given power itself, so that definitely means that n is repeatable, the power is repeatable there, so we are going to return false. Otherwise we are going to subtract power and check for the next smaller power. Okay, this approach seems understandable. Yeah, I got it now. The sum is quite tricky, but it's good. So that's it, guys. That's it for today on LeetCode Daily Question. I'll also come up with another video regarding sliding window, not sliding window, two pointers. Hold on.